In this video, we are setting up a quantum molecular dynamics simulations of a molecule called formic acid using Siam quantum program. Okay, we first start off with using Avogadro to build the molecule. Okay, we start with adding up a carbon on the screen, and then we are making the carboxylic acid, so we need an oxygen with making a double bond to the carbon, and another oxygen that is making single bond. Okay, and then here making the extension and optimized geometry, we are now having the starting structures for the simulations. So I go to File and Save As, and I would say that the name is formic. Okay, so we go to save it in the SQ folder in the desktop. Okay, and choosing the file type XYZ and save. Then close it, and then open up the SQ folder and the command prompt here. Okay, so if you look at the usage of the program, so you can see that there are many options for the quantum molecular dynamics. Okay, so if I do the SQEXE on the formic acid and use the basis set or 321G text, okay, and add the option for the post SCF as the QMD. Okay, and then this will be following by the options within the QMD regime, okay, in which I'm going to add the option keep temp as 300 to keep the constant temperature of 300 Kelvin. And then for the trajectory file, output file, so I've used default thrush.xyz for the time step in picosecond. I will also use the default, which is 0.001 picosecond or 1 femtosecond for each of the time step. And for the maximum number of steps, I choose minus QMD max of 200, so that we can see the events happening in 200 femtoseconds. Okay, and then I push enter. Okay, so what you can see here is the looping process. Okay, so it is alternating between the SCF calculations to solve for the wave function that is the closest possible to the eigenvalues and the eigenvectors of the Schrodinger equations. So that is the first bit here. Then after that, the program will use the electron density profile to calculate the total force within the system. This is what you see at the force calculation. And from the force calculation, using Newton's law of motion, you can specify the new position of your nucleus when the nucleus is moving. And then after the nucleus position has changed due to the moving and due to the force, you are going to need the new wave functions here. Okay, so the process is going to be calculate the wave function and electron density, and then calculate the force, and then calculate the positions, and then we're back to calculate the wave function and electron density again before to calculate the force and before calculate the new positions. Okay, okay, so now we're just killing times to wait for 200 frames to be finished. So the process of molecular dynamics that I mentioned here in quantum molecular dynamics The same process, it's just working for the classical molecular dynamics too. Okay, it's finished. Okay, so now we get the output file called the trash.xyz here. So we open the VMD and then drag the file into the VMD. Okay, and this. Okay, so here is your molecule. And if I move the main window a little bit here, and I click play forward. Okay, so here you can see the motion of the molecules. Okay, so then we are going to use some features of VMD to keep track on the motions of some particular pairs of atoms within the molecules. For example, I click at mouse and label, and I choose bond, or you can simply using short key by pressing number 2. You can see the cursor become a cross, and if you click on any of the two molecules, for example, I'm going to click on this carbon and this oxygen, and you can see that the distance between carbon and oxygen will appear. And then if you click play again, what you can see is the distance of between carbon and oxygen, they keep changing with respect to time. So that means that we can plot these things as a function of time. Okay? And not only the distance that you can measure, you can also measure the angle. Okay, so if I click at number 3, okay, and then I have a click at the same carbon, the same oxygen, and another hydrogen. Okay, so the number in yellow will appear though, so that is the angle in degree. So if I click play again, so you can see that both numbers are changing. Okay, for how much it changed, okay, we can we can make a plot, okay, by going to the graphic and choose the menu level. Okay, and you're gonna see the new window here. So from the new window, click the drag drop and click bond. Okay, so that you can see that if you click it until you get the green cursor here, it will show you the information of the bond or the distance that you just made. Okay, and if you go to graph and click graph, okay, so you can see that they're trying to plot the distance as a function of time. Okay, and that you can also save this as the ASCII matrix. Okay, so I will say that this is the CO distance, and then I save it. Okay. So if you go to your folder and try to make this as a .txt file in order to open with the notepad. Okay, so from here you can see all the informations of the distance for each frame of your trajectory from 0 to 200.